Okay, so let's do today's good daily challenge. It's just been 7 minutes since this question came out. Um, let's start. So the question is: given the head of a linked list, return the node where the cycle begins. If there is no cycle, then I should return null. Okay. Okay. So this is a linked list 3 2 0 -4, and position is at 1 0 1. POS 1 means denote the index of the node. Okay, index of the node that tells next pointer to connect it to 0. There is a cycle in a linked list. If there is some node in the list that can be reached again by continuously following the next pointer, internally POS is used to denote the index of the node that tells pointer next pointer is connected to 0th index. uh, this is -1 if there is no cycle. Note that POS is not passed as a parameter. Okay. Tail connects to node index 1. The cycle in the linked list will tail connects to the second node. -4 connects to 2. And here 2 connects to 1. So if there is no cycle, then return null. So here I need to return it means that return the node where cycle begins. So cycle begins at node -4. So should I return -4 here? Because the cycle begins at node -4. Actually, the cycle can begin anywhere, right? So you can also say the cycle begins at 0. I think that the node is 2 where the cycle begins, because when you are traversing from the start from 3 2, so this is where cycle begins, right? The 2 point. So to return 2, I think. Here we should return 1, and here there is no cycle. Okay. I think I understood the question. So we should solve it using O of 1 constant memory. And the constraints are the number of nodes in the list is in the range 0 to 10 to the power 4, and nodes value goes from negative to positive. So there can be negative numbers, 0 or positive. POS is -1 or a valid index in the linked list. It means, okay, POS is either -1 or a valid index in the linked list. So what is POS again? 0 1 0. I didn't understand the concept of POS. It looks like POS is the result that we are returning here. But let me console and run this one. What is the output? Return value is not the list type. Okay, return it. Suppose. Let me see what is the output. Okay, output tail connects to node 0. So what if I say here next here? Then the output would be head next. What is it? Head dot next. Okay, it means that I need to return this node only, not the position but the node. So 3 2, I need to return 2. Okay, I think I got this POS, what POS means. So POS is just used to denote the index of the node that tail's next pointer is connected to. Okay. So POS actually, it's like you are not even given POS. POS not is passed. POS is not passed as a parameter. We will just look at head only. So what I can do is, here it is like 3 2 0 and 2 -4, right? So I need to find a node where the cycle has started. So what I can do is, from I think there are many approaches, right? Since they are asking us to solve in constant memory, I'm thinking, okay, first of all, I will think of a brute force solution. So, in a brute force way, how would I detect a cycle? To detect a cycle, it would be, I think, to detect a cycle, we should keep track of. I already got to 320 minus 4. I think that to uh to I think that to I think that to 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 detect a cycle, what we should do is, this is I 320 minus 4. Hmm. So first of all, I'll start at this node. So 3 is visited, and I'll go to second node. 2 is visited, and another question is, can there be duplicate values? Nodes in the range. Note that value POS is -1 or a valid index in the linked list. So can the values be duplicate or not? I mean, how would I know if two nodes are equal or not? So suppose 2 is pointing to 2 only, then how would I know? Can I just eh, say that 2 equals to 2? I think so, right? I can just compare node 1 equals to node 2, right? Can I do that? Because this is the object, so can I compare object equal to object? Will it be equal? I don't think so. Like, even for if array A is equal to 1 to 3 and B is equal to 1 to 3 only, then they won't. I cannot compare. Okay, but if they are the same position, then they would be equal, obviously. Suppose if B is equal to A, then this would return true. I'm sure about it. So I can compare object with object. If A is equal to 1 to 3 and B is equal to A, if I'm comparing A with B, then it will return true. So yeah, I can just compare, so it means that I can just keep a visited set, and so 3 is visited, 2 is visited, and 0 is visited, 4 is visited, and from 4 it will again go to 2. So 2 is already in this visited set. That is why what I do, uh, since 2 is already in the visited set, it means that um, it means that there is a cycle. So if the node is in visited, it means there is a cycle, right? So whenever because I'm going through a straight line, and whenever any node would point back, then it means that there is a cycle created, and that cycle started here only. Okay, so that is one technique. But for this one, I need to create a visited set, right? And visited set would take of and space, because I might need to store all the indices here. I was also wondering if I can, because this visited would be an array, can I store a object in the visited set? I think so. So let's code this first and then think about the solution for O of 1 space. Okay, optimization. I'll just ask for the question. Optimization to O of 1. Optimization to O of 1 space. Okay. So how to code this? So first of all, I need a visited set. I need a visited state, and then I'd go until I'd reach um so I'd go until a null position, right? First of all, the value that I'd return is, because when if there is no cycle, then return null, right? So result will be null in the beginning. And if while I'd do head, while head dot next is not equal to null, I think, because I'd go, suppose there is no any loop here, then I would have gone until, first of all, head is 3, then head dot next, uh, then head will be equal to head dot next. So this is the head first, and then in the second head dot next would be this one, this one, and at last it would be null. So if while head so while head is there, until it is there, I'd go, but if head is not there, then I would return result, right? So I'd first of all check if head is in visited or not. If visited dot has head, if visited dot has head, then I would return head. Otherwise, I would just add head to the visited, and then and then um, and then go to the next node. So what I am thinking here is, because I'm adding, right? So in the beginning, the head is equal to 3, so I'm adding the head, and head is equal to 3 in the beginning, so I'm adding head here. Head is equal to 3, and now I am changing head. The head is equal to head the next. So when I'm changing, this will not change, obviously, because I'm not changing its property. Because suppose if I had changed, here that value is equal to 4, then the value in my visited would also change. So that was what I was checking. So okay, this is safe, because I'm just changing the whole value, so this would not change the already inserted elements in the visited. I think this should work. So return it, or I can say, if it is equal, then result would be equal to head and then break. So that I'm doing this so that the return, there would be just one return there would be just one path where we are returning. So we are giving visited state, and if it has this value, then we are then that will be the result. Otherwise we are going to the next value. Yeah, I think this is fine. So even if for 1 and 2, first of all, for 1 and 2 it would be, so this would be the head value first, and then in visited there would be head, and 2 would be inserted in the head, and then again 1 is already there, so we return 1, and for this one we just return null. So 1 would be inserted in the visited, and it would be null here, so we just return null. Okay, this is working, but I should also do it in of 1 space. So how to optimize it to of 1 space without keeping track of visited? What I am thinking right now is, can I keep track, can I just use slow and fast pointers? Because if slow pointer means it will just, a slow pointer means it will traverse the array 1 at a time. So from 3 it will reach 2 to 2, from 2 it will reach to 0, from 0 it will reach to 4, but the fast pointer will traverse 2 at a time. So Yeah, 3204. And so it means that the complexity in this question is, how would I know? I mean, okay, I'll just do it again. So I'll do it with a longer example. E, F, G, H, I, J, K. Suppose there is D, E, F, G, H again. Okay, then this will be the slow pointer and fast pointer. So slow pointer, when slow pointer reaches to the half, A, B, C, D, E, F, G, H, it has started to H, I, J, K. Um, it has started to deviate from this point, right? This is the POS. So slow and fast pointer. So what would happen when fast pointer reaches at this point? Thinking about this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, make it smaller. What would happen if the slow pointer reaches at this point? When the slow pointer reaches at this point, then when slow pointer has completed one cycle, A, B, C, D, E, F, 1, 2, 3, 4, 5, 6, then fast pointer would have reached to 12th position. So it would have reached to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm thinking. So A, B, C, D, E, F, D, E, F. Okay. A, B, C, D, E, F, F to D, D to E, F to F, D. So there is a cycle here from D to F to D to F to D. Okay. So when it reaches at F at this position, so there are 6 numbers, 1, 2, 3, 4, 5, 6 at 6th position, and the number is 3 here. The cycle number is 3. So when it reaches to the end, 1, 2, 3, 4, 5, 6, then it would reach to 6, so 6, 12, 12th position. 12th position means 12 minus 6 is equal to 6. So it means that it would reach the 2, 3, 4, 5, 6, and the length of the repeated number is also 3. So I mean, I was trying to check, when does as slow pointer and fast pointer meet? What I was trying to say here. So because A, B, C, D, E, F. So when it reaches to 1, 2, 3, 4, 5, 6, then where will this also meet at the same position? If this fast pointer also meet at the same position, then it would be great, right? But I'm doubting it. I don't think that when slow pointer reaches at the point where cycle begins, I don't think that fast pointer would also reach the same position, because it depends on the number of the loop, right? There isn't just the 3 numbers in the loop. Suppose if there are F, G, D, E, F, G. Suppose if there is 4 numbers in the loop, then F Z D E F G, then I don't think that it would meet here, because 1 2 3 4 5 6 7, G D E F G G D E F G. There are 4 numbers in the loop right here. Numbers in loop. There are 4 number count. Numbers count in loop is 4, and so when it reaches 1 2 3 4, it doesn't matter, like 1 2 3 4 5 6 7. So when slow pointer reaches to 7, then fast pointer would reach to 14, and 14 means this 7 14 means 14 minus 7, because 1 2 3 4 5 6 7, right? 14 minus 7, 7 times, so it would reach 1 2 3 4 and 5 6 7. It would reach here. So whatever the value is, the position, I mean number of times the fast pointer has traversed. So suppose fast number of travel fn times, then it would be fn minus the actual number here, I mean the actual number here, actual non-loop number, fn minus non-loop count, right? And that percentage numbers loop count is the position where it would reach. So yeah, so 14 minus 7 is 7, and 7% is 4 each. 4 and 4 5 6 7 3, right? So it would reach at this position 1 2 3 4 5 6 7 8 9 10 11 12 13 14. It would reach here, and position in the loop. One, two, three, it would reach here. So when a slow pointer reaches at the end, then fast pointer would reach here. So how to know when slow pointer and fast pointer meet then? When will it meet? In which position would it meet? Because what I'm trying to do is, I'm trying to find the fast number, right? How to even know that there is a loop? I think that if there is loop, then slow pointer and fast pointer will meet somewhere, right? There is a possibility that it will meet somewhere, but so in this case it will meet at, if it is here, then it would be 1 2. It is here, then it would be 1 2. It is here, then it would be 1 2. Okay, so these two has met at position 1 2 3 4. But how would we know? Okay, it has met here, but how do you know where is the start of the loop? That is the problem here. So G D E F G. How to know? I think that there is something formula like this, but what is it? So when slow pointer and fast pointer meet somewhere, should I still go on continuing it, or how do I know when it meets? Maybe I can keep count, right? Maybe I can keep count of this small position where it meets. So suppose if it meets at 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15th position. Right? So it it made at 15th position, right? So it means that the faster has traveled 30 times. Does it keep something? And it's like my instinct is saying that this would mean something because they had met at this point. It means that it should give me some hint that where this has started, or at least it should give me hint of what is the number in loop, right? So it did not. Oh my god, why is this so hard to think about? um, Take a deep breath, look around, and try to think it in some fresh way, in a fresh perspective. Maybe I'm complicating things. That is a simple. um I'm not sure. It is already 27 minutes since I started. Should I look at the solution? No, I should still try. I think I'm close. um 15th position and 30th position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. F is 1, 2, 1, 1, 2, 3, 4, 5. Oh, actually here F, C, D, E, F only. One, two, three, four, five, six, 7, 8, 9, 10, 11, 12, 13, 14. G, D, E, F, G. Z, D, E, F, G. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 2, 3, 4, 5, 3, 4, 5, 6, 7, 10. And 3, 4. One message here, then we will average. 1, 2, 3, 4, 5, 6, 7. 7 reaches to 1. 7 fast pointer reaches to 3, third position. Is it reaches here? 1 2 3 1 2 3 I mean 1 because slow. Okay, it will start at this position. 1 2 3 4 5 oh 1 1 2 3 4 5 6 7 and 8 9. If it is 9, then it would reach 4 2 is 8. If it is 9, then it would reach 14 minus 9 is equal to 9 10 5. 5% is 4 is equal to 1. 1 2 3. But why did, oh my god, what am I doing? 14th position and 15th position. Okay, I look at solution as table. I look at set. Okay, this is what I did. If node is not equal to null, then visit it as, then return node. Otherwise add and do node the next. First of all, it did not just use it, it did not change it. I could also have done that. Otherwise return null at last. Yeah. And float, yeah, that's what I was trying to do here. What happens when the fast runner races a slow runner on a circular track? The fast runner will catch up to slow runner from behind. Separate into distinct phases. In the first phase, it determines whether a cycle is present in the list. Yeah, I was also trying to do the same. First of all, I know that when these two pointers meet, then I know that cycle is present. But what I did not know is how to find the beginning. Otherwise, it uses the, if no cycle, it returns null immediately. Otherwise, it uses the located intersection node to find the entrance to the cycle. Okay, how do I find the entrance to the cycle? Here we initialize two pointers, slow and fast. Until here can no longer advance, we increment tortoise once and here twice. If after advancing them, here and tortoise point to the same node, we return it what? Otherwise, we continue. What is it doing? Okay. Okay, it meets. It made at point 2. Right? It made at point 2. Now what? Oh, okay. Sorry. Okay, so if it meets at point 2, then pointer 1 starts at 1 and pointer 2 will be here. Pointer 1, pointer 1, pointer 2. Okay, what? What is it doing? It means that whenever, suppose if my slow and fast pointer meet somewhere, then I can start from the beginning again. And if I start from the beginning, then I will reach then the okay, if I start from the beginning and 1 2 3 4 5 6, so it means that in the same position where I'll reach in the start of the cycle, this pointer will also reach at the start of the cycle. I mean, why is that so? I didn't understand that. So okay, I know that this uh this tortoise here made here, and I know that it is a cycle here, but why I mean, in step one, two, three, and step one, two, three, how is this step the same as where this tortoise and here meet? How is the step from where the tortoise and here meet to the beginning of the loop uh, equal to the step from beginning to where you start to the loop? How is that so? Like, what is the mathematics here? Why did I not get it? I didn't understand. Like, uh, it means that one, two, three. So it reaches to the start at one, two, three, right? Okay. It means that I think it is making sense. It means that it will. So there are three steps until we find a loop here. There are three steps, one, two, three. So wherever the here and tortoise meet, there will be three loop left. I mean, there will be three steps left to reach to the beginning. That is so because I think that one because if suppose if the loop started from 0 point, okay, from point zero only, from zero, if it started, then it would go from 0 to 1, the slope pointer would reach to 1, then slope pointer would reach to 2, 3. So it would reach to it would be easier if I could show you guys what I mean in a table, but I'll just try to explain from this figure only. It would be easier to explain it in a graph, I mean in a drawing sheet. Okay, sorry. From 0 to 1, yeah, from 0 to 1, 1 to 2. So it would always if it started from this from the beginning only, it would reach from 0 to 2. When it reached 3, then it would to 2, then it would reach, I mean, um yeah, I mean, it would always, if it started from the beginning, from the 0, I mean, if the loop started from the first index only, then it would always meet in the first index, because when from 0 to 1, 1, 2, 3, 4, 5, right? Because when the tortoise takes one loop and comes back to position 0, the here would have completed two loops and come back to 0 at the same time. When here is at 4, then tortoise would be at, oh sorry, when tortoise is at 4, from 0, 1, 2, 3, 4, then the here would have reached to position 3, I think, yeah. 0, 1, 2, 3, and 4, yes, that is true. So if the loop had started from the beginning, then it would reach, it would just uh it would just it would just meet in the beginning only, because we are just moving it two times. So it means that whatever is the offset is equal to the first distance that is required from beginning to the start of the loop. Yeah, I think I got it. So if it takes 6 positions to reach to the beginning of the loop, then tortoise and hare will also meet at the position 6 steps behind the start of this loop. If it takes one position, if it takes, if it starts from the beginning of the loop, then it would meet in the beginning of loop. If it starts from here, from one position behind, then it would meet at one position behind. I think that makes sense because the loop, how it behaves is, and that's true. Yeah, it would always meet at the start of the loop. If it would have started in the start of the loop. I think I get it. So I don't think I should write the code anymore, but I got the point. Let's see the explanation. Initialize two pointers of, I think they will say the same. The nodes in the cycle have been labeled the non-cyclic nodes. This is because here traverses 2f over course of x and exactly f of which are a cycle. So it's obviously node points to uh, h plus 2h minus c. Given that I think they are telling the same thing that I said. Uh, Initialize two more pointers. Can harness the fact that they move twice as quickly to assert that when they meet at node edge, here has traversed twice as many nodes. Using this fact, we deduce the following. So 2d is equal to d. That means 2f plus a is equal. They are they are like using entire mathematics, which I was trying to do also. I was trying to use mathematics and whatnot, but I think when I saw this diagram, it was clear to me how to find out the uh, the start point using fast and slow pointer. Got it. Okay, bye guys. Thank you for watching. I will always post a video that I made while I first saw the question because I don't know, I always like things that is phrased and that is really raw instead of making a video after I had looked the solution once or things like that. Okay. Okay, bye.